When drawing free body diagrams, make sure you follow these tips. Always draw a single dot or a square to represent the objects. Always draw arrows pointing away from the dot. The arrow tails must touch the dot. Arrow lengths should indicate relative magnitude. Label all the forces and make sure that you call them the force of something. You imply that there's a force. Don't just say gravity or springs or tension or anything like that. And then don't break it into X and Y components unless specified. So, to start with, we have here a dog sleeping on the ground. Don't worry about drawing a dog. We just draw a square or a circle to represent the dog. The most obvious force on this dog is gravity, and gravity always pulls straight down. We'll label this our force of gravity. And the dog is in equilibrium, it's just sitting there sleeping on the ground, so we draw a force that balances out the force of gravity. And in this case, since the dog is on the ground, this is going to be our normal force. Now for our next one, we have a marble after it has rolled off the table. We ignore air resistance. So the first thing we realize is that the table, it's completely irrelevant. It's already rolled off the table. So we draw our marble in the air, represented by this box. And then, again, sticking to the tips, we draw our arrows that are vectors representing the forces. In this case, the marble is falling from the table, is already fallen from the table, so we have gravity, of course, pulling downward. And then we label that Fg, F gravity. And since it's off the table, we're ignoring air resistance. There are no other forces acting on it. In this case, we have a sign hanging by two wires that are 40 degrees from the horizontal. So to start with, we'll draw our sign, or rather a box that represents the sign. Gravity is, of course, pulling straight down. And now, this is where it gets a little tricky. We have our two wires that are 40 degrees from the horizontal. So they'll be coming out in this direction. But we're worried about the forces. The sign is at equilibrium. So that means that there has to be some sort of force that is completely opposite side of gravity and it's balancing it out. But there is no wire there. Instead, we have two wires that share this balancing force, this tension. And so each wire is only going to exert half of the balancing force. So that means the X component of our wires has to come roughly halfway up. In other words, when we draw this, we'll draw our arrows at an angle, roughly 40 degrees to the horizontal. And as you can see, the X component of these two vectors comes about halfway up our balancing arrow, which means that together, the X component of these two vectors balances out gravity, the force of gravity. Now it will indicate that our angle, theta, is measured from the horizontal. And we'll say theta is equal to 40 degrees. Now, we don't want this here. That's sloppy. So let's erase that.